All right. So let's look at the thing. So it says now suppose you get a positive test result. What are the chances you have cancer? So what do we already know? Do we already know they tested positive? Or do we already know that they have cancer?
Yeah, they have.
So we know they tested positive. So maybe, hopefully you still remember, but what does this symbol mean? Start with a G.
And
Can you ask that again?
given that.
What did this symbol represent? Start with a G, I.
Just say given that.
Cool, perfect. Does that mean the given that? So anything that come after given that, that means that's what we already know. So since you already told me we already know they test positive, we'll put positive right here. And we want to find the probability they have cancer. All right. So far, everybody go with the notation. So if you remember, this corresponds to the probability of cancer and positive, and you divide this by the probability of the given, which is that they tested positive. All right. Everybody good so far with this notation? So sign. Yes. Okay, so let me label these again. So this is A, this is B, this is C, this is D. So if I'm trying to get the probability somebody has cancer and they tested positive, which of these branches would I want to use? A, B, C, or D? Which branch give me a positive and that they have cancer?
A.
Yeah, so you want to just use A. Okay, A would give me they have cancer and they test positive. You don't want to use C, because if you look at C, it does give me they test positive, but this one give me no cancer. So we want it to be cancer and that they test positive. So that's why you only want A, not A and C. So that means for the top, we'll put A, which is 0.01, and you multiply by 0.80. Everybody good? 0.01 times 0.80?
Yes.
All right. So up next in the bottom, if you look at the bottom we want the probability that they get a positive test result. So how many different ways can I get a positive test result based off of this tree diagram that I drew? Like, are there only one of them that give me a positive test result, or are they multiple branches that give me a positive test result?
Multiple.
Cool, they're multiple. Which one's one of them?
A and C.
Cool. So A, but also C. Because if you look at A gave me a positive test result when they have cancer. But if you look at C gave me a positive test result when they don't have cancer. So the bottom, you're going to put both of those. So in the bottom, we'll put 0.01 times 0.80. And we'll also do 0.99 times 0.096. Everybody good so far how I got the denominator?
Mm-hmm.
Well, for B doesn't represent that. So Samantha, when you're talking about B, you're talking about this B right here? So that be would that be represent that they have cancer, but the test result was negative. So they do have cancer, but when they took the test told them that they don't have cancer. So that's actually called something called false negative, because a false negative when they say you don't have cancer, but they actually do have cancer. Does that kind of make sense, Samantha?
Yeah.
Right. Right. So what should I do with these two value in the bottom? Like which sign should I put in between it?
And or
Adam?
Well, is the operational one,
You multiply?
not multiply. If you remember from the notes, we actually just added them.
Add.
Yeah.
So you just want to add those two values.
Someone said it, but it's like broken up.
Was broken up?
Yeah.
No plus. There you go. All right. So what I'm going to go ahead and do, I'm going to go ahead and do the calculation right now to see what do it calculate to be. So for this one, I'm actually going to do it in class calc. Everybody see right now class calc?
Yeah.
mm-hmm.
All right. So right here, we do the math for this. So we're going to do 0.01. And let's multiply it. And we're going to multiply it by 0.80. Then we're going to add it 0.99. And we're going to multiply this by 0.096. As you look right here, you get 0.10304. So this is what the bottom give me. Everybody good with the 0.10304 represent?
Mm-hmm.
Yes.
Okay. So now I'm going to do 0.01 multiplied by 0.80. And what we're going to do, we're going to divide this by what we got in the first one, which is 0.10304. And if you look right there, you get 0.0776. So say 0.0776. And that's your answer. Any question? I got the answer. Right. So let's do the next one. Any question for this last one that I did? All right, so we're gonna do one more for this one, and then that will be it for Bayes' theorem. So right now, what I want you to do, I want you to set up this table. Not the table, I want you to do the tree diagram. So for this one, we'll do the same thing. We'll say cancer, no cancer. You'll say they tested positive or they tested negative. Same thing, if they have no cancer, tell me what percent of them tested positive for that test, what percent tested negative for that test. So right now, all I want you to do is just be able to set up that tree diagram. Everybody kind of know what they're doing right now?
Mm-hmm.
Cool. And if you have questions, just put a question on the chat and I'll help you out.
I know. I was expecting, but then
Oh my God, everyone. We can.
All right, so I'm gonna unmute everybody so that way we could kind of talk what should go in A, what should go in B, what should go in C, and so on.
But if Landon was a little sure, make it.
So is A 0.01?
Cool. So A should be, here, let me get a different color. So we'll say A is 0.01. Yeah, so A should be 0.01 because it say 1% of women over 50 have breast cancer. So if 1% of women have breast cancer, what percent don't have breast cancer?
99.
Yeah, 99. That's 0.99. All right. Everybody good so far for A and for B?
Yes.
All right, let's try C. So what should C be?
90.
90.9.
So put 0.90. So if C is 0.90, what the B has to be?
0.0.
Yeah, 0.10. All right, so what does E have to be?
0.80.
Yeah, so it should be 0.80. No, 0.08. So that means F should be what?
It's 8%. Oh,
Yeah, 0.92.
8% of women were having false positives.
Cool. All right, so that's how you set up the table. Any question on how to set up the table? Oh, sorry, the tree diagram? Cool. Let me check something happening on chat. All right, no, perfect. All right, so up next, we're gonna look at the last sentence. So the last sentence, if you look at it, it says, what are the probability that a woman has cancer if she has a positive mammogram result? So in this one, if you know, they're telling us she has a positive mammogram. So if they're telling us that she does have a positive mammogram, where should the positive go? Should it go here in A or should it go here in B? So if you want, you can either shout it out or on chat, you can just say either A or B.
A.
Well, remember for this one, we already know she tested positive. So if we already know she tested positive, where should it go?
B.
B. So you put the positive right here. And for this one, we want to put cancer in A. Can you just remember anything that we don't know? You put that in the first or before the given that. Anything we do know, we put that after the given that symbol. So for this one, you put positive after the vertical line and you put cancer before the vertical line. All right.
can you repeat that again? You put what when you do know?
Cool. So anything we know, we put it here. So we know. You put anything right here, we no, sorry. We don't know. So for cancer, if you look at it, it says find the probability they have cancer. So we don't know what the chances that they have cancer. But if you do notice for B, we already know they tested positive because they tell us she has a positive test mammogram. So that's why we know after the vertical line should be positive, before the vertical line should be cancer. Any question in regard to that? Sweet. All right, so up next we're getting to the notation. So for this one, we'll say probability they have cancer and test positive divided by the probability they test positive. So for this one, we're gonna have to see which of the 4 branches do we want to use. So I'm gonna label this A, B, C, and D. So which branches should which branch should I use if I want it to be cancer and be tested positive? Cool, so I'm already getting the answer, perfect. So yeah, so you want to use A. So for A, you're gonna use 0.01 and 0.9. So that would go on top. They put 0.01 times 0.90. All right. Any question why that go on top? All right. So which branches should I use if I just want them to test positive? Because in this case, we don't care if they have cancer or don't have cancer. We only care if they tested positive. So which of the 4 branches should I use? A, B, C, or D? Cool. So A and C are perfect. So we're going to use branch A. We're also going to use branch C. So we'll say 0.01 times 0.90 plus 0.99 times 0.08. Any questions so far how I got that? What's your question? Where are you saying? Well, the reason why I'm setting up that way, because if you kind of remember, we said branch A and C goes here. So since A and C go there, in order to get the probability for branch A occurring, you have to get the probability of cancer and they tested positive when they have cancer. So you get 0.01. So that's where the 0.01 come from and the 0.90 from there. And then if you look at branch C, you get 0.99 from here. And you also get the 0.08 because that's a positive test result. So that's how you get the 0.99 times the 0.08. Everybody kind of good with that? So up next, what I'm going to go ahead and do, let's see, where does the 0.10 come from? Well, the 0.10, if you look at D, this is where the 0.10 come from. But the 0.80, there's no 0.80. I think you're talking about 0.08. 0.08 come from over here. Well, the 0.10 and the 0.90 have to make up 1. So if you do 0.9 plus 0.10, it's 100%. But also, if you look at the 0.8, it's come from right here where it says 8%. So this 8% here is why we put 0.08 over here. Because if you look right here, it says 8% of women will have false positive. So they're telling us 8% will have false positive. False positive means that they don't have the cancer, but they tested positive for the cancer. So that's what they represent when they say a false positive. Any question in regard to that? Yeah, so false positive means that they tested positive, but they don't have the cancer. So if they ever say you have a false positive, that means that you tested positive, but actually the test was wrong. So you're saying the test result was wrong. Okay, so up next, I'm going to go ahead and just calculate this. So let me calculate this in class Cal. So if you calculate that, you should get 0.102. And that's it for that problem. Any question in regard to that last problem? And if you want, you could get taught. You don't get taught to get chatted.
No.
Cool. All right. So the next thing that we're going to go over is something mathematical that you should have known, but if you don't know, it's okay. I'll teach you right now. So the next chapter we're going to, chapter 4.4, is called counting. So one thing that you have to know in regard to do this chapter or section, you have to know what this symbol represents. This means factorial. So what the factorial telling you to do, it's telling you to get that number.
There's a seat here. Excuse me. Were you gonna go over the examples on page 22?
No, pretty much all you're gonna leave that just for extra practice, because those are just pretty much extra practice, because we already did 3 of them.
Okay, that's fine.
Yeah, because I usually always leave those for extra practice since Bain's theorem, the one that kind of is tougher on students. So I'm giving you some example of questions that I can ask.
Can we go over those tomorrow? Like, can you have the answers up for those tomorrow? in the
Yeah,
lab?
yeah. So tomorrow we could go over them if you want. So if you want me to go over them during laboratory, you just show up during laboratory from 3 to 4:05, and I'll help you out.
Mm.
All right. So whenever you have a factorial just means that you get that number in that factorial and you keep on multiplying by every number smaller than that number until you finally get to 1. So if you look at the example right here, I have 4 factorial. So that means you get 4 multiplied by 3, multiplied by 2, multiplied by 1, and you get 24. So say if I have like 5 factorial, that means you get 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. And if you multiply that out, you get 120. Everybody get where the 120 come from?
Mm-hmm.
Cool. So say I want you to do 6 factorial right now. So practice on 6 factorial. Tell me what do you get?
Is there a function for that on the calculator?
Let me look for it. There might be.
Oh, I found it.
Okay, cool. Yeah, if you go right here, it's right there.
That's 720.
$720.
Perfect. All right. Everybody go with factorial?
Mm-hmm.
Okay, sweet. So let's do this first problem. So it says a byte in a sequence of a number, all either 0 or 1. The number of possible bytes is how much? So for this one, how many numbers do we have?
1.
Well, well, we have one number. How many digits will that one number have?
Oh, 8.
Yeah. So you're saying you're gonna have one number. It could be like 0, 1, 0, 1, 0, 1, 1, 1. So it should have a number, and all the numbers should be either 0 or 1. So for this one, what I want you to tell me is how many options do I have for the first number?
1, 2.
Cool. So I have 2 right here, correct? How many options do I have to put there?
2.
2. You have 2. You have 2. You have 2. 2. You have 2. Everybody good so far on that we have 2 options for each one of those numbers? So for this one, if I wanted to find the number, you're gonna multiply. No. All right, what's your question in regard to why? Okay, cool. So when I need by 2 options, so you know how we could either choose 0 or 1? So that means this number right here could either be a 0 or it could be a 1. So that's what I mean when I said we have two options. So we have two numbers that we could pick from. So if they would have told us it could be 0, 1, and 2, now instead of having two options, now we technically have three options. So whenever I say how many options, I'm saying how many different numbers can this number be? So there's two different numbers. Everybody good so far? Cool, perfect. All right. So once you find out how many options each have, all you're gonna do is just multiply them. So we're gonna say 2 times 2 times 2 times 2, 4, 5, 7, and 8. So pretty much 2 to the 8th power. So if we do 2 to the 8th power, that's fine with that.
256.
2 to the 8th power, you got 256. So that's how many total different sequence of number I could choose if I have two options for each one of those numbers. All right. Any question for that one? All right. So let's do
Can
this.
you repeat?
Repeat which portion? So pretty much the 256 is telling me how many different numbers I could choose if I'm trying to choose 8 sequence of numbers. And I only have an option of 0 and 1. So that means there's a total of 256. So that means one of the options could be 0, 0, 0, 0, 0, 0, 0, 1. That's one of the options. So the 256 is telling me I have 256 different options I could choose from. Everybody good for that last round?
Mm-hmm.
All right, so let's do this last one, and then we'll check that thing with the class and see how we go. So for this one, so the iPad uses a 4-digit code where the digit has to be a number from 0 to 9, and the number can repeat. So for part A, it says how many different passcode can be created. All right, so
4.
for this one, how many digits do we have to pick for a number?
9.
4.
About 9?
4.
You sure about 4?
36.
Well, let's list all of them out. So we could choose 0, we could choose 1, we could choose 2, 3, 4, 5, 6, 7, 8, and 9. How many numbers do I have there?
9. Wait.
1, 2, 3, 4,
8.
5, 7, 8, 9.
10.
We have 10 numbers. 10 number. So that means we have 10 options. But the thing is, if we're going from 1 to 9, that's 9. But if we're going 0 to 9, you have 10 options technically.
Oh.
Okay. Everybody go that we have 10 options to choose from.
Yeah.
All right, so let's do A. So A is saying how many different passcodes can be created. So we have to choose 4 digits. So here goes the first digit. Here goes the second digit. Here goes the third digit. And here goes the fourth digit. So when I'm picking the first digit, how many numbers do I have to choose from 0 to 9? Yeah, cool, 10.
Wait, so then the number is going to be really big.
It should be really big. So what about for the second number? How many options should I have to choose from for the second one?
10.
Cool, 10, perfect. What about for the third one?
10.
What about for the fourth one?
10, 10, 10, 10.
10.
Perfect. 10, 10, 10. So once you get all of the options of how many outcomes are possible for each one of those, all you're gonna do multiply it. So we're gonna say 10 times 10 times 10. So we'll say 10 times 10 times 10 times 10.
Wait,
And
why are we multiplying them again?
so you multiply them because that's going to give us how many total options we have, or how many total different passcodes we have to choose from. So for this one, we'll have 10,000 different passcodes. Everybody get on the 10,000 different passcodes?
Mm-hmm.
All right, so let's do B. So for B, it says, what is the probability someone can randomly guess the passcode correct in the course of time? All right. So we want to find the probability and guess correct. All right. So when we're guessing, how many different options do we have to choose from?
10,000?
Oh, 10,000.
Well, we have 10,000. Perfect. Of those 10,000 passcode, how many of those passcode will open up your iPad?
4.
1.
4.
So you're telling me your
1.
iPad has
1.
different passcode?
Oh,
1.
It should be 1, correct? Because there's only one unique number that should open up your iPad or your iPhone. So let's do 1 divided by 10,000. You get 0.0001. And that's it for B. Any question for B? So let's do C and then we'll call it a day. For C, it says, what is the probability that someone cannot randomly guess the passcode correct if they have 3 attempts? So if you kind of notice the first one, they only had 1 attempt to guess it correct. And this one, we don't want them to randomly guess the passcode correct. So we want, when they guess 3 times, we want them to get all 3 of the time incorrect. So we have the first attempt, we have their second attempt, and then we have their third attempt. So what is the probability that in the first time they attempt to, I'll ignore it. What's the probability that the first time that they guess on their passcode that they actually get it incorrect?
Oh, incorrect.
Incorrect.
Oh,
So how many incorrect passcodes are there?
3.
9,000.
So 9,000 and what?
9,999.
Perfect. Out of how many?
10,000.
Cool, 10,000. All right. Everybody good how we got 9,999 divided by 10,000? All right. So let's do the second one.
9,998
Perfect. Why is there 1 less?
because you already used the first attempt.
Yeah, correct. Like if you're smart, you're not gonna attempt the same passcode. Cause if the first passcode didn't work, you're gonna test out a second passcode, which hopefully you think that one should work. So which number should I put on the bottom though?
9,999.
Perfect. All right. So that'll be the third attempt. So for the third attempt, which number should I put on top?
9,997.
Now 9,997 out of 9,900.
998.
So far, everybody good with those probabilities?
So they keep changing because you keep using them, right?
Correct. They're changing because, like, if you're a smart person, you wouldn't attempt the same passcode over and over again. Because say if you had tried that the passcode 001, it's not like the second time you try it, you're gonna try that same number. You're gonna try a new number. So that means there's one less number for you to choose from.
That's only if you're smart.
Yeah, that's the thing. They're
Only if
smart.
you're smart.
If they're not so smart, they keep on using the same number. Like, we can't help them. So if we actually work this out, you should get 0.9997. And that's your answer. So that's it for today's lecture. Any question for this last part?
So how did you get the 0.997? Did you just divide?
Yeah, because pretty much what's going to happen, you're left with this, and you divide it by 10,000. So if you do 9,000, so you're going to do 9,997, and you're going to divide it by 10,000. And that's how you can do that. But that's it for C. And that's it for page 23. Any other questions? All right, so we're going to stop the recording.